So in this question, we're asked to propose a structure given a molecular formula. So the first thing that we're going to want to do with this question is to do the HDI, because that will tell us some basic information in terms of whether there's a pi bond or a ring in the molecule. So our molecular formula for this question is C5H10O2. So to put that, or to solve the HDI, again, our HDI calculation is going to look like this. So it's going to take 2 times the carbon atoms plus 2. We're going to subtract the number of hydrogens and the number of halogens. So that halogens, again, we consider to be fluorine, bromine, chlorine, or iodine. We don't have any of those in this example, but just make sure we're clear on that. And we are going to add the number of nitrogens. We ignore the number of oxygens. So in this case, we have 2 oxygens, but those are not taken into account in our HDI calculation. And we're going to take all of that and divide it by 2. So for this example here, we have 5 carbons. So we're going to take 10 plus 2 and then subtract 10, which is the number of hydrogens. We're going to divide that by 2. So that gives us an HDI of 1. So again, this tells me that I have either 1 pi bond or 1 ring in my molecule. And again, we're given a lot of leeway in this question, so we could incorporate either pi bond or a ring into this example. So now what I need is I have a 5 carbon chain, I have 10 hydrogens, and 2 oxygens. So there's a variety of different functional groups that we can draw with 2 oxygens. So one of them is an ester. So again, that would incorporate one of my pi bonds and an oxygen. So again, this could be my molecule here, or my functional group. So this would have 2 carbons. To complete my molecule, I need to draw 3 additional carbons. So we'll put 1 carbon on this side and then 2 on the other side. And that would get us to a molecule. So again, 1, 2, 3, 4, 5, 2 oxygens. And then if I count up the number of hydrogens, it's good to confirm that we have the correct number of hydrogens. So I'm going to fill those in here. So again, on my terminal methyl group, I have 3 hydrogens here. So that would be 3. I have 2 hydrogens here. So that would be 5. 2 here would be 7, and another 3 would get me to 10 hydrogens. So that is one structure. Again, we can think about sort of moving different pieces around as well to create different constitutional isomers. So I could take one of the this methyl group on this side of my ester here, and basically think about moving it to the other side over here. So in this case, that would create a carboxylic acid. So my functional group would look like this. So carboxylic acid. And then I would have essentially 4 carbons coming off to get me to my 5 carbon chain. So 1 carbon, 2 carbons, 3, 4. So 1, 2, 3, 4, 5 total. So again, count up the number of hydrogens to make sure those match. So I have 1 hydrogen here, going to have 2, another 2, that gets me to 5, another 2 gets me to 7, and 3 would get me to 10. So these are just 2 examples. There are a variety of other examples. So actually I'll do one that incorporates a ring. So we'd have 5 carbons and 2 oxygens within a ring. So I guess if we put that all together, that would be 5 atoms of carbon, 2 atoms of oxygen. So I'd have to draw a 7-membered ring with 2 oxygens in it as a possibility. So I can go ahead and try and draw that. So here is my oxygen, 1 carbon, 2 carbons, 3. I'm going to put my oxygen here. So 1, 2, 3, 4, 5, 6, and 7. And that would get me to the corresponding correct number of hydrogens as well. So let's add those up just to make sure that those are correct. So 2 hydrogens here, 2 hydrogens here, 2, 2, 2, 2, and 2. So again, I have 1, 2, 3, 4, 5 carbons, 2 hydrogens on each. That gets me to 10. So again, here are just 3 examples. There are many other examples that we could do, but again, this incorporates a ring, and here are 2 different functional groups that contain our pi bond and form our carbonyl.